From a distance, Venus seems like a familiar face in the vast expanse of space. It is similar in size and mass to our own planet, earning it the title of Earth's twin. However, this resemblance is merely superficial. As we delve deeper, we uncover a world shrouded in mystery, a stark contrast to the vibrant blue oasis we call home. Venus beckons us with the allure of the unknown, inviting us to unravel its secrets and understand the forces that shaped its fiery destiny. The second planet from the Sun, Venus is a world of extremes. Its atmosphere, a thick shroud of carbon dioxide, traps heat with an efficiency that belies its beauty. Beneath this oppressive blanket lies a landscape sculpted by intense volcanic activity, a testament to the planet's turbulent nature. Yet, amidst this inferno, scientists have begun to uncover tantalizing clues that hint at the possibility of life, challenging our understanding of where life might exist in the universe. Venus is a planet consumed by a runaway greenhouse effect, a phenomenon that has transformed it into a world of extremes. This effect is a cautionary tale of climate gone awry, illustrating the delicate balance required to maintain a habitable environment. The thick atmosphere, composed primarily of carbon dioxide, acts as a giant blanket, trapping the sun's heat and raising surface temperatures to an unbearable 900 degrees Fahrenheit, or 475 degrees Celsius. This intense heat is a direct result of the greenhouse gases that envelop the planet, creating a feedback loop that perpetuates the extreme conditions. This heat is so intense that it would melt lead, making Venus the hottest planet in our solar system, hotter even than Mercury, despite being farther from the Sun. The surface of Venus is a scorching inferno, where metals like lead and zinc would exist in a molten state, flowing like rivers of lava. Adding to this hellish environment is the atmospheric pressure, a crushing force 90 times greater than what we experience on Earth. This immense pressure is akin to being 3,000 feet beneath the ocean's surface, a depth that would crush most submarines and make human survival impossible without advanced technology. Standing on the surface of Venus would be equivalent to being 3,000 feet beneath the ocean's surface, a depth that would crush most submarines. The pressure is so intense that it would flatten any human-made structure not specifically designed to withstand such extreme conditions. This immense pressure, combined with the searing temperatures, creates a truly inhospitable environment, hostile to life as we know it. The surface of Venus is a place where conventional life forms would be unable to survive, making it one of the most extreme environments in our solar system. The atmosphere itself is a toxic cocktail, dominated by carbon dioxide and laced with clouds of sulfuric acid. These clouds, rather than bringing life-giving rain, unleash a downpour of corrosive acid that evaporates long before it reaches the scorching surface. The sulfuric acid clouds are a stark reminder of the planet's volatile nature. The atmosphere of Venus is not just hot and pressurized, but also toxic. The thick clouds of sulfuric acid create an environment that is corrosive and deadly. Any spacecraft attempting to land on Venus would need to be equipped with special materials to withstand the acidic conditions. These clouds, rather than bringing life-giving rain, unleash a downpour of corrosive acid that evaporates long before it reaches the scorching surface. The acid rain on Venus is a phenomenon that highlights the planet's extreme and hostile nature, making it a challenging target for exploration. This hostile atmosphere, a stark contrast to Earth's life-sustaining air, poses a significant challenge to the search for life on Venus. Despite these extreme conditions, scientists continue to study Venus, hoping to unlock the secrets of its past and understand how it became such a hostile world. The study of Venus not only helps us understand our neighboring planet, but also provides valuable insights into the potential future of our own planet if we fail to address climate change. In 2020, a team of scientists made a startling discovery that sent ripples through the scientific community. This discovery was not just another piece of the cosmic puzzle, but a potential game-changer in our understanding of life beyond Earth. They detected phosphine gas in the Venusian atmosphere, a finding that was both unexpected and intriguing. Phosphine is a molecule that on Earth is associated with life, particularly in environments devoid of oxygen. Phosphine, a molecule composed of one phosphorus atom and 3 hydrogen atoms, is considered a potential biosignature, a chemical indicator of life. Its presence in the atmosphere of Venus, a planet long thought to be inhospitable, opens up new avenues of scientific inquiry. On Earth, phosphine is primarily produced by microorganisms in oxygen-starved environments, such as swamps and the intestines of animals. These microorganisms thrive in conditions that are harsh and extreme, suggesting that life can adapt to a variety of environments. The presence of phosphine in the Venusian atmosphere, especially in quantities that cannot be easily explained by known geological or chemical processes, raises the tantalizing possibility of microbial life existing in the planet's clouds. This discovery challenges our preconceived notions about where life can exist. These clouds, while still acidic, offer a more temperate environment compared to the scorching surface, with temperatures and pressures more akin to those found on Earth. The idea that life could exist in such an environment is both exciting and humbling. This discovery, while not definitive proof of life, has reignited interest in Venus as a potential abode for life beyond Earth. Scientists are now re-evaluating past data and planning new missions to further explore this enigmatic planet. It highlights the importance of looking beyond Earth-centric biases in our search for extraterrestrial life, and considering the possibility of life adapting to environments that we once deemed uninhabitable. This discovery serves as a reminder that the universe is full of surprises, and our quest to understand it is far from over. As we continue to explore our solar system and beyond, the detection of phosphine on Venus will undoubtedly be a focal point for future research. It encourages us to develop new technologies and methodologies to detect and study potential biosignatures in diverse environments. The journey to uncover the mysteries of Venus is just beginning. With each new discovery, we inch closer to answering one of humanity's most profound questions. Are we alone in the universe? The detection of phosphine on Venus is a significant step in this ongoing quest, reminding us that the search for life is a journey filled with wonder and endless possibilities. The potential for life in the Venusian clouds presents a fascinating challenge to our understanding of life's limits. Venus, often referred to as Earth's twin due to its similar size and composition, is a world of extremes. Its surface temperatures can melt lead, and its atmospheric pressure is crushing. Yet, high above the surface, in the thick, acidic clouds, conditions are less hostile and might just be suitable for some form of life. Any organisms inhabiting this environment would need to be incredibly resilient, capable of withstanding high levels of ultraviolet radiation. The clouds of Venus are filled with sulfuric acid droplets, and the sunlight that penetrates these clouds is harsh and unfiltered. Scientists have been conducting experiments to understand how life could adapt to such conditions, using UV radiation testing on various materials and simulating harsh environments in laboratories. The presence of sulfuric acid is one of the most significant challenges. On Earth, sulfuric acid is highly corrosive and can destroy most organic materials. However, some microorganisms have been found to thrive in acidic environments, suggesting that life on Venus, if it exists, might have developed unique adaptations to survive in such a hostile setting. The lack of liquid water is another major obstacle. Water is essential for all known forms of life, and its scarcity on Venus raises questions about how life could sustain itself. They would need to thrive in a world where the sun is a distant, hazy glow, and the air is thick with sulfuric acid. Extremophiles on Earth, organisms that thrive in extreme environments, provide a glimpse into the potential adaptations that life on Venus might employ. These organisms have evolved to survive in conditions that would be lethal to most other life forms, such as deep-sea hydrothermal vents and acidic hot springs. Organisms that thrive in extreme environments such as deep-sea hydrothermal vents, where temperatures can exceed 400 degrees Celsius and pressures are immense, have developed unique biochemical mechanisms to survive. These mechanisms might offer clues about how life could exist in the Venusian clouds. Similarly, life forms found in acidic hot springs, where the pH levels are extremely low, have adapted to survive in such harsh conditions. These extremophiles have evolved unique biochemical pathways that allow them to neutralize the acid and thrive. If life exists on Venus, it might have developed similar adaptations to cope with the acidic environment. These hardy organisms have evolved unique biochemical mechanisms to survive and even flourish in conditions that would be lethal to most other life forms. Researchers are studying these extremophiles to understand the potential for life in extreme environments, and their findings could provide valuable insights into the possibility of life on Venus. However, the challenges for life on Venus are immense. The planet's atmosphere is composed mainly of carbon dioxide, with clouds of sulfuric acid, and the surface temperatures are extremely high. The lack of liquid water, considered essential for life as we know it, poses a significant hurdle. Without water, the biochemical processes that sustain life would be difficult to maintain. The lack of liquid water, considered essential for life as we know it, poses a significant hurdle. Water is a solvent that facilitates the chemical reactions necessary for life. On Venus, any water present is likely to be in the form of vapor, making it difficult for life to sustain itself. Scientists are exploring the possibility that life on Venus might use alternative solvents or have developed entirely different biochemical processes. Additionally, the intense UV radiation from the sun could be detrimental to any organic molecules. UV radiation can break down complex organic molecules, making it difficult for life to develop and sustain itself. However, some microorganisms on Earth have developed mechanisms to repair UV-induced damage, suggesting that life on Venus might have similar adaptations. While the discovery of phosphine is intriguing, much more research is needed to determine if life truly exists in the Venusian clouds. Phosphine is a gas that, on Earth, is associated with biological processes. Its presence in the atmosphere of Venus has sparked interest and debate among scientists. Some researchers believe that it could be a sign of microbial life, while others argue that it could be produced by non-biological processes. And if so, how it survives in this alien environment. The search for life on Venus is ongoing, and future missions to the planet will aim to gather more data and provide a clearer picture of the potential for life in the Venusian clouds. Understanding how life could survive in such an extreme environment will not only expand our knowledge of life's limits but also inform our search for life on other planets.